You're standing at a river crossing. It's roughly 300,000 years ago, and across the water, another group is doing the exact same thing you are, filling water skins, watching the treeline. They are not your species. They never will be. There's no way to ask them where they came from. There's no shared language between you. There's no guarantee this meeting ends peacefully. And here's the part that should genuinely surprise you. This wasn't a rare event. Around this exact point in time, researchers count at least 8 different species of human. Not ape, not ancestor. Actual upright, tool-using, fire-controlling humans sharing the same planet at the same time. This is not a story about human evolution as a straight line, one species patiently turning into the next. Not a ladder. Not a single chain leading in a straight march to you. The truth is messier and far stranger. A crowded family tree with branches that overlapped for hundreds of thousands of years before almost all of them went silent. Branches that hunted the same herds, competed for the same caves, and in at least a few documented cases, had children together. Here's the real question worth sitting with before we go any further. If there were 8 of us, what happened to the other 7? Start with the one still standing. Homo sapiens, us, emerged in Africa roughly 300,000 years ago, based on fossils found at a site called Jebel Irhoud in Morocco. But we were, for most of our existence, the newcomer in a room that was already full, arriving late to a world other humans had already been shaping for close to 2 million years. Homo erectus had already been walking the planet for close to 2 million years by that point, the single longest-running human species there has ever been. They controlled fire, made tools, and migrated out of Africa long before we existed. A 2019 study led by researcher Russell Sayashan found evidence that a population of Homo erectus survived in Java, in what's now Indonesia, until perhaps as recently as 108,000 years ago, meaning our species may have briefly shared the planet with the very first one to leave Africa at all. Then there were the Neanderthals, thick-set, cold-adapted, living across Europe and Western Asia for over 300,000 years. Closely related enough to us that nearly everyone with non-African ancestry alive today carries a small percentage of their DNA. They weren't the brutish stereotype either. Evidence from multiple sites shows deliberate burial, symbolic ochre use, and care for injured group members who survived injuries that would have been fatal without ongoing support from others. And the Denisovans, known mostly from a single finger bone found in Denisova cave in Siberia, and sequenced in 2010 by geneticist Svana Pabo's team. A species we only know existed because of what its DNA left behind in modern Tibetans, Melanesians, and East Asians today. A 2025 study even identified a skull found in Harbin, China back in 1933 as belonging to this same species, sitting misidentified for nearly a century. Here's where it gets genuinely strange. On the island of Flores, in Indonesia, researchers Peter Brown and Mike Morwood uncovered, in 2003, the remains of an entire human species barely 3.5 feet tall. They named it Homo floresiensis. The wider world nicknamed it the Hobbit. And it likely survived on that isolated island until around 50,000 years ago. Small not through disease or deformity, but through island dwarfism, the same evolutionary pressure that shrinks large animals isolated on small islands over enough generations. Here's a real question worth asking. How does an entire population of humans end up the size of a child? The mechanism is called island dwarfism, and it happens because a small, isolated environment with limited food simply cannot support large-bodied animals across many generations. So body size shrinks to match what the island can actually feed, generation after generation, until an entire new form of human results. Barely a few hundred miles away, on the island of Luzon in the Philippines, an entirely separate small-bodied species was discovered in Kalau Cave and formally described in 2019 by researcher Flores, Detroit. They named it Homo luzonensis, distinct enough in its teeth and finger bones to be its own species entirely. Evidence that island dwarfism happened not once, but independently, at least twice, in the same region of the world. Then, almost unbelievably, in 2013, cavers exploring the Rising Star cave system in South Africa found bones belonging to an entirely unknown species, deep inside a chamber that can only be reached through passages barely wide enough for a single body to squeeze through. Researcher Lee Berger's team described it as Homo naledi in 2015. Its brain was roughly a third the size of ours. And yet dating published in 2017 placed these remains at only 236,000 to 335,000 years old, meaning a small-brained, primitive-looking human species was very likely alive at the exact same time modern humans were emerging, not some safely distant ancestor at all. Here's why that date shocked the field so badly. Everything about Homo naledi's skeleton looked ancient. A brain that small was expected on a creature over 1 million years old, not something breathing the same air as us. Small brain size, it turns out, was not automatically the same thing as being simple. Researchers have found evidence suggesting naledi deliberately carried bodies deep into that cave system. An act that starts to look uncomfortably close to intentional burial. And behind most of these, quietly, sits Homo heidelbergensis, living across Africa and Europe starting roughly 700,000 years ago. Widely considered the common ancestor that eventually split into Neanderthals, Denisovans, and modern humans, the branching point where one lineage became at least three. Skilled enough to hunt large game with wooden spears. And likely the first human species to build simple shelters rather than relying purely on caves. 8 species, overlapping ranges, overlapping time. And for a stretch of at least 100,000 years, every single one of them was, at the same moment, somewhere on this planet, alive. Reindeer and mammoths, meanwhile, had the comparatively simple job of just trying not to get eaten by whichever human species showed up that week. Honestly, respect for managing it as long as they did. So here's the uncomfortable turn. Of those 8, only one is left. Homo erectus faded out roughly 100,000 years ago. The hobbits of Flores and Luzon vanished within the same general window. Neanderthals and Denisovans were gone by around 40,000 years ago. Naledi's exact ending isn't well dated at all, which is its own quiet kind of unsettling. We don't fully know why. Climate shifts, competition for the same shrinking resources, disease carried by an expanding new arrival, and in at least some cases, absorption through interbreeding rather than outright extinction, all likely played a part, in different combinations, in different places. The honest answer is that no single explanation covers all 7 disappearances, and anyone claiming total certainty is guessing. What the evidence does support is that modern humans were expanding into nearly every one of these territories right around the time each species disappeared from it. A pattern too consistent across 3 continents to be pure coincidence, even without a single tidy cause. What's certain is this: for most of the time humans have existed on Earth, being the only kind of human around was not the normal condition. It was the exception. You are, right now, living inside the one unusually lonely chapter of an otherwise crowded story, roughly the last fraction of human history where there has been exactly one of us instead of several. So back to that river crossing, 300,000 years ago, 2 different kinds of human watching each other across the water. Neither of them could have known that one lineage would eventually be the only one left standing, telling this story, wondering what it was like when there used to be more of us.